This is problem 8-88, and now we're moving on to B. We're supposed to figure out if this is proper scientific notation or not. And we notice that this first factor is less than 10, and it's larger than or equal to 1. And the second factor is a power of 10, so it's a base 10 with a power. So both of those are correct. So this is correct scientific notation. All right, so let's look at C. And C is 2.8 times 10. And it looks like the first factor is less than 10 and larger than or equal to 1. That part's okay. This is 10, but it doesn't have a power. So maybe what we need to do is fix that. So 10 to a power of 1 is equal to 10. So we're going to rewrite this as 2.8 times 10 to the power of 1. And that makes it correct scientific notation. All right, so the last one is D. That is 0.83 times 10, or actually 100 to the second power. Okay, so the first thing that we notice is that this is less than 10, but it's not larger than or equal to 1. So this actually needs to be bigger. And what we would need to do is we would need to move the decimal point over 1 to make this a bigger number. So we actually need a 10 from someplace else, and that someplace else is going to be here. So the other thing we notice is that this is not a power of 10. This is a base of 100 to the power of 2. So we need to convert this to a base of 10. So I know that the 100 is 10 times 10. That will make 100. And then this whole thing is to a power of 2. So if I wanted to figure out what the real value of this is, I'd have to take this 10 times 10 times 10 times 10. So this is really 10 to the fourth power. All right, so I do need to borrow one of these 10s so I can increase the value of the first factor. So I'm going to just make this second factor 10 to the third power, and then I'm going to increase this by 110, so it's going to be 8.3. All right, so that is now correct scientific notation for this amount.